This is a problem where we have a box with 10 tickets, 4R and 60s. We're supposed to draw out 2 tickets with replacement. So we're going to draw 2. And we're supposed to find the chance that at least one is R. There are 2 methods to do this. I'm going to show you the long way first so you understand why we want to do the second method later. So this is the long method. You can do this when you only draw something twice. If you're going to draw something, say 10 times, this would take you hours to try and figure out. Okay. But long method, we can do it with just 2 draws. So if you think about it, if you want a chance that there's at least one R, then what are the things that would let you actually do that? You could draw red, and then you could draw, an R and then a D. Or you could do a D and then an R. Or you can do an R and an R. All of those options would be at least one, right? It can be red and D, or R and D, or D and R, or R and R. So those are the things that would have at least one. All right, so if I was to find the probability of those, I find the probability of R and D, or D and R, or R and R. So remember, when we have an and, we're going to times. So if I want a red and, I'm sorry, I keep saying red, it's just habit out of so many probability problems. If I have an R and a D, first I want the probability of an R. There are 4 R's out of 10 total, so I would have 4 out of 10 as my chance to get an R. Then I'm going to times, now I want a D. Now remember, this is with replacement, so we put everything back, so there are still 6 D's out of a total of 10. Okay, plus, now I'm going to do the D and R. So D, we start with 6 out of 10, then we put it back, and now we want an R. Because we put it back, there's still 4 R's, there's still 10 total, nothing has changed. Then I want an R and an R. Well, the first time I draw, there are 4 R's to choose from out of 10 total. But then I put it back, so now there are still 4 R's to choose from out of 10 total. I put all that together, and I get 64 out of 100. So again, remember, I multiply when I see an and whenever I see an or, I'm going to add. So I've done all that, but that is the long method. If I want the short method, we do what's called the complement rule. The complement rule says, well, we did at least one R up here, but that can take a while. Instead, you can think of what's the complement of at least one. Okay. It turns out the complement is 0. Okay. So that always works. Anytime I tell you find the chance of at least 1, the opposite is going to be 0. So instead, the probability of at least 1 R is going to equal to 1 minus the probability of no R's, or 0 R's, depending on how you want to write it. So that will always work. The probability of at least 1 R is always going to be 1 minus the probability of no R's. So we'll do this 1 minus. What's the probability of no R's? How do you actually get no R's? The only way to actually get no R's is to get a D and a D. So what's the probability of a D and a D? Well, the first time there would be 6 out of 10 D's. The second time we put it back, so there would still be 6 out of 10 D's. If you put this into your calculator, you should get 64 out of 100. Now, I don't care if you put your answers as fractions. I don't care if you simplify your fractions. I don't care if it's a decimal or a percentage. Any of those are going to work and be fine on the exam. So that's 64 out of 100. You could simplify it to, let's see what. I'm going to do this wrong in my head. 16 out of 25, or you could write it as 0.64 as a decimal, or you could write 64%. If you don't remember how to change this, go back and look at our math skills for changing between fractions, decimals, and percentages. Again, it doesn't matter how you do it. If your calculator gives you decimals every time, that's just fine. I love decimals. If you have fractions, that's just fine too.